Hello everyone, welcome back to my YouTube channel. In today's class, we are going to learn about spherical mirrors. This is one of the most important topics in light and reflection. By the end of this class, you will clearly understand what is spherical mirror, what are their types, the important terms like pole, center of curvature, principal axis, focus. Okay, let's start the class. Okay, we'll start with spherical mirrors. So, what are spherical mirrors? Spherical mirrors are mirrors whose reflecting surface forms a part of a sphere. The surface of these mirrors can be curved inwards or curved outwards. Based on this, spherical mirrors are divided into two types. So, first is concave mirror, another one convex mirror. So, let me take a simple example to explain concave mirror and convex mirror. So, you know about glass ball, right? Transparent glass ball. Just imagine you have a spherical ball or a transparent glass ball. If you cut this ball into two equal parts, what will you get? You'll get two curved surface, right? So now let's take a one of this part. If you paint outer side of the surface, the inner side becomes reflecting surface. This type of the mirror we call concave mirror. In this case, reflecting surface is curved inwards. The mirror which is having reflecting surface is curved inwards is called concave mirror. Okay, now let us take another part. Take another part. If you paint the inner side, then outer surface become reflecting surface. This type of the mirror we call convex mirror. Here reflecting surface is curved outwards. So based on which side is reflecting inwards or outwards, we classify spherical mirror into two types, that is concave mirror and convex mirror. Okay, then what is meant by concave mirror? A concave mirror as its reflecting surface curved inwards. That means it faces towards the center of the sphere. I'll explain what is meant by center of curvature, everything I'll explain. So you just remember the definition. Concave mirror as its reflecting surface curved inwards. This means it faces towards the center of the sphere. Because of this inward curve, concave mirror can converge light rays. Okay. Next, convex mirror. A convex mirror has its reflecting surface curved outwards. This mirror diverges the light rays, which means the rays spread out after reflection. Okay, let us understand this with a simple real life example. Take a spoon and observe it carefully. When you look at the inner side of the spoon, it acts like a concave mirror because the surface is curved inwards. Now, look at the outer bulge side of the spoon. This side acts like a convex mirror because surface is curved outwards. So, with just a simple spoon, you can easily understand the difference between concave and convex mirror. In exam, usually they will ask activity based question. Let us understand very important activity. So how a concave mirror works. Okay. First they given caution in your textbook. So never look directly at the sun or into the mirror reflecting sunlight. It can harm your eyes. Okay. So take a concave mirror, hold it in your hand, and the reflecting surface of the concave mirror it towards the sun. Now hold the sheet of paper in front of the mirror. Just you are holding the mirror, the reflecting surface of the mirror is towards the sun. Then hold a sheet of paper. Take a sheet of paper, you keep in front of the mirror. You will see sunlight reflecting from the mirror onto the paper, right? So when the reflecting surface of the mirror is towards the sun, what will happen? Sunrise, if fall on the mirror, reflecting surface of the mirror. Usually the reflecting rays you can see on the paper. Slowly move the paper back and forth. After some time, you will notice a bright spot, sharp spot of the light on the paper. So observe the diagram. Now keep the mirror and the paper at the correct position for a few minutes. Okay. So what will happen? The reflecting rays are falling on the paper now. So what do you observe? You will see that paper start heating up and may even burn. Okay. So this activity clearly shows that concave mirror can converge light rays and produce heat at the focus. This particular point we call focus. Okay. Students, when we are discussing about spherical mirrors, it is very important to understand the terms related to them. You already know about spherical mirrors and their types, correct, right? A spherical mirror as some important terms. These are pole, aperture, focus, focal length, principal axis, radius of curvature, and center of curvature. We will discuss them one by one. First, let me draw a concave mirror. This is a concave mirror. The first term is pole. So what is pole? We can easily identify the midpoint of the mirror. I'll represent this one with P. This is the midpoint of the mirror. Let me label it as P. So midpoint of reflecting surface of spherical mirror is called pole. One more time. The midpoint of reflecting surface of spherical mirror is called pole. Okay. I hope you are clear about definition of pole. Okay. Next one. So what is aperture? What is mean by aperture? As I told you, mirror is a part of spherical ball. If you cut the spherical ball, you will get a spherical mirror. Now, if you draw the diameter of reflecting surface, the diameter of the reflecting surface of spherical mirror we call aperture. I'll repeat the definition. The diameter of reflecting surface of spherical mirror is called aperture. Okay, next spherical term is center of curvature. The center of curvature is represented by letter C. The center of curvature is the center of the sphere. So you know about sphere, right? So sphere as a center. That center of the sphere from which mirror is formed or mirror is a part is called center of curvature. So the center of curvature is slightly vary with types of the mirror. Suppose in concave mirror, center of curvature lies in front of the mirror. So you observe the diagram. Here in concave mirror, center of curvature is in front of the mirror, right? Reflecting surface is inwards. Center of curvature is in front of the mirror. In convex mirror, center of curvature lies behind the mirror. Convex mirror reflecting surface is outward. Center of curvature is present behind the mirror. So position of the center of curvature is depends on types of the mirror. Okay. Next, let's talk about radius of curvature. This radius of curvature is denoted by letter R, capital letter R. So this is the distance between pole and the center of curvature. Okay. Radius of curvature is nothing but distance between pole. You know the pole. Midpoint of the mirror is called pole from P to C, center of curvature. Whatever the distance is there, that one we call radius of curvature. So you can write another way. Radius of the curvature is the radius of the sphere from which mirror is formed. I'll repeat. Radius of curvature is a radius of the sphere from which mirror is formed. Okay. So this is radius of curvature. So another thing, principal axis. Principal axis. So you learned about pole, radius of curvature, center of curvature. If you draw any straight line from pole to center of curvature, that line we call principal axis. Okay. So imaginary straight line that passes through pole and center of curvature. Okay. This line is very important. This principal axis, the line is very important because all the main ray diagrams are drawn with respect to principal axis. Okay. Okay, now let us understand important relationship in spherical mirrors like a formula. So you know about focal length and you already learned about radius of curvature. Okay, there is a relationship between focal length and radius of curvature. So that can be written as F is equal to R by 2. F means focal length, R radius of curvature. That means focus lies exactly halfway between the pole and the center of curvature. Okay, so this relationship, what I told, F is equal to R by 2, this is true for both concave mirror and convex mirror. Then from this formula, we can write R is equal to 2 into F, or twice of the focal length. Radius is always twice of the focal length. Okay, so if you know the radius of curvature, you can find focal length easily. Or if you know the focal length, you can find out radius of curvature. So this is very important formula. We can expect 2 marks simple numerical based on this formula. Okay, read this question carefully. The focal length of concave mirror is 2 meter. Find the radius of curvature. So use the formula. You know relationship between focal length and radius of curvature. Just you write down the formula. R is equal to twice of the focal length. R is equal to 2 into F. They given focal length in the numerical. So just substitute the value R is equal to 2 into 2, it gives 4 meter. That means focal radius of curvature of a concave mirror is 4 meter. Okay, let me solve another numerical. Find the focal length of convex mirror when radius of curvature of the mirror is 5 meter. Here they given radius of curvature. We have to find focal length. Let's solve in simple way. Radius of curvature they given r is equal to 5 meter. So we know the formula. F is equal to r by 2. Focal length is equal to radius of curvature divided by 2. Just substitute the values. So F is equal to, in the place of r we can write 5. F is equal to 5 by 2. 5 by 2 is nothing but how much? 2.5 meter. This type of the numericals are very easy. Just you have to remember relationship between radius of curvature and focal length. Okay, now let us understand uses of concave and convex mirror. First, we'll go with concave mirror. Okay, concave mirrors are used where we need to focus light or magnified images. Second uses, they are used in shaving mirror and makeup mirror because they give magnified images. So whatever the mirrors we are using as a shaving mirrors and makeup mirrors, those are concave mirrors. Okay. Next, third uses, they are used in torches and vehicle headlights to produce strong beam of light. Next, fourth one, they are also used in solar cookers to concentrate sunlight. So this is very important uses. Concave mirrors are used in solar cookers to produce strong beam of converging light. Okay, next, what are the uses of convex mirror? Convex mirrors are used where we need to see wide field of view. So they are used as the rear view mirrors in vehicles. So side mirrors are there, no? Those are convex mirror because they shows larger area. Then one more use, they are used in security mirrors like a jewelry shop, shopping malls and roads. We are using convex mirror as a security mirrors. These two are uses of convex mirror. Okay, these are the uses of concave mirror and convex mirror. Okay, students, I hope you understand clearly about spherical mirrors and their terms and their uses. In next class, we will learn about ray rules and ray diagrams. If you found this video helpful, please subscribe to the channel and share with your friends. Thank you, everyone.